So we're going to learn about hyperbolic functions here, and they're sometimes called rational functions. So we learned last time about inverse proportionality, and it kind of looks like this. Hyperbolic functions are what happens when you move these left and right and squish or stretch them up and down. So let's have a look. They have a pretty standard form. It looks exactly like this, a over x take b. Now, the b value tells you where your asymptote is. Your asymptote is this vertical line that kind of goes down, and the function doesn't really exist there. Then it's always going to have another asymptote in here at y equals 0. So we call this one the horizontal asymptote. Remember, asymptote has a p in it. It's a very strange spelling. And this one we call the vertical asymptote. Cool. All right. So that's great. The other thing you need to know is that the y-intercept, so y-intercept equals minus a over b. Okay. Now, if you want to rearrange that, this is another useful form. You can times both sides by b and get a equals minus b times the y-intercept. And that form is really useful for finding out whatever your a value is, which we'll see later. Okay, first thing we're going to do is sketch this function. So we'll need a scale. I'm going to go 1, 2, 3, 1, 2, 3, just like that. Now, I know that my vertical asymptote is this number 3 at the end here, and the form of the equation already has a take in there, so that's great. That means that my vertical asymptote is just going to be at positive 3. So it's weird, because it's kind of in the reverse. Since it has a minus in the formula, the asymptote is at positive 3. But if the formula had a plus in it, the asymptote would be at minus 3. It's kind of weird, it goes backwards. All right, x equals 3 is our asymptote. So the other thing that we need to do is find our y-intercept, and we're going to use this formula right here. Y-intercept equals minus a over b, and in our case, a is this top number, and b is this bottom number. So our y-intercept is minus a over b, which is minus 6 over 3, which is minus 2. So I'm going to put that in right now, minus 1, minus 2. My y-intercept is sitting right there. Now, it always has this other asymptote at y equals 0, so we'll put that asymptote in, just like this. And then your function's going to have two pieces. So it could be up here and down here, or it could be up here and down here. But since we already know it has this y-intercept down in this bottom left corner, I know it's this one that I've drawn. So bottom left and top right. Basically, draw it coming down to the asymptote. And what happens with this blue line is it gets really close to the red line, but never quite touches it. Then you're going to draw it up here. Same thing's going to happen. It's going to get really close to the red line, but never quite touches it. And then we've got this one here. It's going to come down and go right. And we label this y equals 6 over x take 3. Just like that. Okay, so let's check our Desmos and see what we're doing here. Basically, y equals 6 over x take 3. We're going to be graphing, and it looks exactly like what we've drawn. It has that y-intercept at minus 2. And if I draw in a line at x equals 3, you'll see that the graph just barely misses this green line. Like, it never really touches it, but it gets really close. In fact, it gets infinitely close. It will never quite touch this green line. It'll always be a tiny bit off. And if you go on the up way, like if we go up, it'll do the exact same thing up here. Never quite touch the green line, but it will get pretty darn close. All right, next thing we're going to do is see some pictures of graphs and then get the equation from here. So they've said here the asymptote is at x equals 4. That should be very helpful. And it looks like our y-intercept is at minus 3. Great. So let's look at our equation. Y equals a over x take b. And I said that b was going to be the asymptote. So this now looks like y equals a over x take 4. 4 is the asymptote. Now, how do we work out what a is? Well, we're going to use that formula that I showed you before. This one right here. A equals minus b times your y-intercept. So, a equals minus b times y-intercept. So b was 4, so that'll be minus 4. And then your y-intercept is minus 3. So a equals 12. So your final equation is going to look like this. Y equals 12 over x take 4. Just like that. And you always should check your answer. So if I look at this, 12 over x take 4, we can see it looks pretty good. So our asymptote is sitting there at 4. And then we've got this here. Our y-intercept is at -3. All right, now let's look at this one. It seems like our asymptote might be at -3 here. It's just barely touching that. And our y-intercept here is at 1/3, basically. So y-intercept equals 1/3, x asymptote equals -3. So our equation usually would look like this. It's going to look like a over x plus 3. So because our asymptote is negative, we're going to get a plus in this formula. Just remember it's backwards to what it would usually be. So let's use this formula up here. A equals minus b times the y-intercept to find our a value. So minus b. B, we know, is -3. Because that's our asymptote. -3 times, and our y-intercept is 1/3. So that's going to be +3 times 1/3, which I think just gives us 1. So that's cool. A is 1. It's good to know. So our final equation is going to look like y equals 1 over x plus 3. Let's see. So y equals 1 over x plus 3. Great. It's got our asymptote at x equals -3, and it's got a y-intercept at 0.33333, like what the graph said. Cool. Next question. It looks like our asymptote is at x equals 5, and our y-intercept is 0.2. So that tells us our equation looks like a over x take b. So a over x take 5, and we know our b value is 5. So let's use our formula. A equals minus b times your y-intercept. So a, and that y-intercept is 1 over 5, by the way, because that's 0.2 as a fraction. A equals -5 times 1 over 5. So I think a equals -1, if I'm not mistaken. So our final equation is going to look like this. Y equals -1 over x take 5. Let's see if we can get that going in our Desmos. Cool. So we got the y-intercept we wanted, and then we've got that asymptote of 5. So the main thing to be careful of in this topic is just your pluses and minuses, making sure you get those right.